So let me just make sure that we got this. Factored form is what we've been working from. We're going to write it in standard form, which is what we've been doing. The only difference now is we are working with functions. So I've got a y equals, f of x equals, all of those things. Nothing new. Have I done anything new? No. Here is the only new thing. Now I have a value of k that is greater than 1. That's all, they've all been 1 so far. Now it's a 2 or a 3 or whatever greater than 1. Now, I typically highlight this, ladies and gentlemen, because I will forget it. Put an arrow there. Do something, because if you don't, you'll forget, much like I still do sometimes. Because what we have to do now is bring that 2 down, because it has to be multiplied. It has to be distributed. Do what we normally do, and then distribute the 2 at the end. So 2 times x squared, and we're going to put the y equals because now it is a function. So 2 times x squared is, yep. 2 times negative 3x is, yep. 2 times negative 4 is, there it is. That's it. So the only thing new is we are going to put a y equals in front because we are going to talk about functions, but we have to distribute a k value that is larger than 1. Okay? Let's go to example B. And again, like I said, I gotta make sure I do something here. Make sure I don't forget it. Okay. So, but for now, I'm going to cover it up, and I'm just going to work these like I typically do. X times x is always x squared. X times negative 2 is negative 2x. Negative 5 times x is, negative 5 times negative 2 is a, there it is. Okay? Then, as always, we combine the like terms, and we get x squared minus 7x plus 10. Okay? Now what do we do? Yep. And we multiply it. We distribute that 3. Okay? 3 times x squared is, I agree. 3 times negative 7x is, I agree. And 3 times 10 is, yep. Make it a function by putting y equals in front of it. I do want to show you what this 3 is on the outside real quick. And we're going to talk a little more, no, a lot more about this tomorrow. Look at these numbers, these coefficients, 3, negative 21, and 30. What number will go into all 3 of those? 3. 3 is a GCF, greatest common factor. We're going to deal with those tomorrow. But just to let you know, what's on the outside there is a greatest common factor. Okay? All right. Any questions about how to get that answer? Get the answer to number 6 for me, please. I'll give you just a couple seconds to do that. Or not seconds. I'll give you a minute to do that. Okay. I'll leave this one up there for you to look at. Alrighty. You can check your answer with mine. Questions? Any questions? Okay. Let's talk about the next situation with intercepts to zeros. All right, so we're not going to write these in we're not going to write them in standard form. We just did that. We're pretty good at that. But what we are going to do is we're going to determine x-intercepts and zeros. Those words are synonymous. They mean the same thing. If I say find the intercepts, I expect you to do that. If I say find the zeros, it's the same idea. Here's how it works. Look at example A. What I want to know is, what can I put in for x? What can I substitute for x that would make y equal 0? That's what I want to know. So I'm looking at this x, and for every variable, for every x, that's what we're going to do. We're going to find the x-intercepts or the zeros. So as I look, what would this x value need to be so that this parentheses equals 0? What minus 1 equals 0? 1. Here's my other one. What would this x value need to be in order for this parentheses to equal 0? 3. There it is. These are my intercepts, or my zeros. Here's how it works. I set them up. If I didn't know what the answer was, I would set this equal to 0. X minus 1 equals 0. And then I would solve it. Everybody please write that. Okay? And I would solve it. The inverse of minus 1 is plus 1 to the opposite side. That's my 0. X equals 1. There it is. And then I have another x here, so I got to do it again. X minus 3 this time equals 0. And then I would solve it. The inverse of minus 3 is plus 3. There's that 0. X equals 3. And that's how I get the other one. So what we're doing here is setting each set of parentheses that has a variable in it equal to 0 and solving. Or if you can look at it and say, oh, I know that 1 minus 1 is 0, there it is. I know that 3 minus 3 is 0, there it is. So it's actually the same number opposite sign, right? That's what we do to get zeros. Okay? So the k value, or the 2, is not a variable, so I don't have to worry about it. All right, let's look at example B. So in example B, what I want to know is, what do I substitute in for x to get y equals 0? So here's what it is. For the first parentheses, what plus 4 is 0? Negative 4. It's the same number, opposite sign. This one is positive. I need a negative 1 to get a 0. And for the second one, what would I need to have to make positive 2 0? Negative 2. And that's the answer. Those are my intercepts, or my zeros. Questions? Any questions? All right, get the answer to number 10 for me, please. All right. What would I need x to be in order for this to equal 0? 3. need this x to be in order for this to equal 0? Okay? Either one of these, if they equal 0, since it's all multiplication, the whole y would equal 0, correct? Because if 3 minus 3 is 0, what's 5 times 0? 0. What's 0 times x minus 1? 0. So that is why we have to find what will make a 0 for each set of parentheses. Okay? Questions? I'll turn the page. Okay, so an explanation of that is in this chart right here. Okay, what we just did, in case you want to look at it, where you have f of x or y equals these binomials multiplied together. I set it equal to 0. Each one set equal to 0 will give me my answer. G of x, still same thing, it's still y, basically. But this is if the number outside, if the k value is greater than 1, I still don't deal with that because it's a number. You can't change numbers. You can't substitute in for numbers. You can substitute in for variables, but not numbers. Okay? So what we're going to do here in example 3 is, what if I give you the information and I want you to write the function in factored form? So what I'm going to give you is, here are the x-intercepts. In this case, we're going to use 2 and 5. Okay? So those are the x-intercepts. And instead of writing this 3 times, we're just going to choose one. We're going to use this middle one, k equals -2. That's the only one we're going to use there. So here's what I have. Y equals, my k is -2. Remember, k is the number on the outside. Okay. Then here are my parentheses. I've got an x and I've got a 2. Because these are my intercepts. Okay. I've got an x and I've got a 5. Those are my intercepts. So I know that they're going to go there. The reason I can go ahead and write them is because this is actually, this 2 is the intercept. It's the x. So if this is 2, what operation do I need in order to make this a 0? Minus. 2 minus 2 is 0. Okay, now my 5, this is my 5. Remember, the intercepts are what the x's are. So if 5 is here, what operation do I need to make this a 0? So 5 minus 5. These are your x's. But you know, in order to get a 0, you've got to have the opposite number to go with that. So if this is a 2, I need a -2. If this is a 5, I need a -5. Okay? All right, let's do example B. So I'm going to do a few of these to get the hang of it. All right, and this time we're going to use k equals 2. And this time my intercepts are -3 and +4. All right, so here we go. Is everybody with me? Okay. So y equals, my k value is a +2, so it goes on the outside. Okay. Now, x and 3, remember we're just writing the numbers, x and 4. And then we're going to determine what sign goes inside. Okay. So this is -3. What do I need this one to be? +3. This is 4. What do I need this to be? Finding the zeros. Making my binomials equal 0. Questions? Okay, we're going to go down to number 13. And this one we're going to use k equals 7. Okay? All right, here's what I know. I've got intercepts -7 and 3. So here we go. Y equals, k is my outside number, so 7 on the outside. I've got x and 7, x and 3. Okay. If this is -7, what does this one have to be? +7. If this one is +3, what's this one got to be? There it is. Questions? Okay, here's the homework for this section. 17 and 18 are like what we just did, and it's going to give you 3 k values. I only want you to use one. So write this down. For number 17, I need you just to do -2. Do k, just do the k equals -2. For number 18, use k equals 5. You're just doing one for each of those like we just did in our notes, okay? All right, turn the page. That's also going to be, that's listed in Google Classroom too, in your classwork. And the homework pages are there too if you need them. Okay, now we're going to apply the zero product property. And here's what it says. And these are the words and everything. Here's what it means. If A times B equals 0, no matter what these are, if they equal 0, then either A equals 0 or B equals 0. Because when we multiply and we get a 0, doesn't one of those have to be a 0 to get there? Okay? So, example A. This is the same exact idea we just did. Here we go. For this one, what does x have to equal? So that is 0. +15. What does this x have to be so that this equals 0? -7. Again, you can set them equal to 0 and find that answer. Okay? If you need to work them out, I would expect you to do so. If I'm looking for zeros, that's how we're going to do it. Set it equal to 0 and get those answers. Okay? Questions. The one that we really need to discuss is D. Everybody look at D. When I look at D, what would x need to be so that f of x equals 0? 12. I agree. But as I said, make sure that you have a value for every x. So that takes care of this x, but I have another one on the outside here. What would the value of this x need to be so that f of x would equal 0? What? Negative? No. Thank you, though. Because it's multiplication. What would I need to have here that when I multiplied it, it would be 0? 0 is correct. So remember, one of them has to be 0. This one would be if x were 12, that gives me my 0, and x times 0 is 0, therefore f of x equals 0. But the one on the outside would then have to be 0 because 0 minus 12 is negative 12. 0 times negative 12 would give me 0. So make sure you are including all of your variables when you're telling me how to get a 0 for my equation. Okay? Questions? Okay. As a reminder, the K value in front is a number. We don't substitute in for numbers. Okay? So when I look at number 6, what would the X value have to be here in order for this to equal 0? What minus 13 equals 0? Positive 13. 13 minus 13 is 0. Okay? What would the value of this X need to be in order for this parentheses to equal 0? Negative 12. Same number, opposite signs. Questions? All right, turn page. This is where it gets a little exciting. Look at example A and tell me what you notice about example A. Tell me. Do what? It equals 0 instead of y equals. Yes, it does. What else do you see? I have k values in front of both of them. That is true. What else do you see? Very good. The binomials are the same. Here they are. X minus 4, X minus 4. So that's important as well as y'all pointed out, they have k values greater than 1, both of them do. So here's what we do. What would this x value need to be in order for this to be a 0? Positive 4. What would this k value need to be? This x value need to be in order for this to be a 0? Positive 4. Do you think I need to write that twice? No. So this is how we do it, and that's why. Because we have the same x value there, correct? So here's what we do. The numbers in front, 3x plus 5, becomes my first binomial. Then, the binomial that is exactly the same, we only write it once. And this is how we find the zeros. First of all, we know what this one is. We already discussed that. That one is x equals 4. Can you tell me by looking at this what this x should be? Negative 5 times 3 is a negative 15, plus 5 is a negative 10. What? 0. 3 times 0 is 0, 0 plus 5 is 5. I like it. I like it. But what we're going to do with this one is we're going to set it equal to 0. Because the answer is no, Miss Langley. I cannot figure that out just by looking at it. So here we go. 3x, I'm going to put it over here to the side. 3x plus 5 equals 0. Subtract the 5. Makes that one go away. So now I've got 3x equals negative 5. Divide by the 3. And that's what we get. Negative 5 over 3. Leave it as a fraction. We don't change it to a mixed number. We leave it as a fraction. So the other x value is negative 5 over 3. Now, do you want the shortcut? Yes or no? You sure? This is positive, right? So my answer has to be negative. Still have to have opposite signs. Watch this. Constant over coefficient. If you can remember that, then that's all you have to write. If you can't, then just work it out to make sure you get the correct answers. It's only a two-step equation, okay? Okay? All right, so let's go over here and let's try that shortcut method. Here we go. First of all, here are my binomials that are exactly the same. They only get written once because there's only one zero or intercept in that. I got -9, and I got plus 3x. Now, when I write these, I am going to write my variable term first because that's the way we usually write them. So 3x and -9, x plus 2. If you write -9 plus 3x, that's fine, but make sure that you know which one's the coefficient and which one is the constant. I just prefer to write them that way. Now, this first one, we already know. What should x be in order for this to equal 0? -2. Okay? My second one here, constant over coefficient. Okay? The constant is the number that's all by itself, right? What kind of 9 is it? Negative. So my answer has to be the opposite, which is positive. Constant over coefficient. Always simplify your fractions. Questions? Okay? Number 8. I'm sorry, number 9. Number 9 does not have two parentheses that are exactly alike, but I can make it like that. What will go into 3 and 18? 6 will not go into 3. There it is. Okay? So I have -8x times x plus 6. This is a positive 3. What I divide by goes on the outside, x plus 6. Like I said, we're going to work with that a little, we're going to work with that more tomorrow. I just kind of want to throw that out there to you. So if you don't have two matching binomials, find a factor that you can divide into those. Okay? So here we go. X plus 6 only gets written once. But then on the outside, I've got -8x plus 3. All right. So I've got -8x plus 3 is my first binomial. X plus 6 is my second one. What plus 6 equals 0? -6 plus 6 equals 0. So that one is -6. I need a -6 here in order to make this one a 0. My second one, I've got a negative, so what's the answer got to be? Positive. What over what? 3 over 8. Constant over coefficient. And that's the answer. Leave it as a fraction. Questions? Okay? This is your homework for this section. Okay? It's just the odds, and it's just the odds on that first page, so make sure you're just doing the odds, okay? Any questions? Okay.